Okay, so I'm gonna show you guys how to do how to balance a redox reaction using the oxidation method or the bracket method. You can do the half reaction method, but that's gonna take a really long time as opposed to this. So here are the steps. The first thing you have to do is assign oxidation states and numbers. You have to assign it and then follow along with the brackets, and then you cross multiply. I'll explain that later. The second thing that you have to do is check and balance to see that every element in the equation is balanced itself, like the coefficients are balanced. Next, you add either hydronium ions or hydroxides. If you're balancing under acidic conditions, then you use this. If you're balancing under basic conditions, then you use hydroxides. And after that, you just add water to balance the remaining hydrogens. So for step one, I have this reaction. It's from a lead oxide, lead acid battery. So what happens here, we have lead oxide, and we have lead sulfate. So the first thing we have to do is assign oxidation numbers. So lead, oxidation number is 0. Okay, here, -2 times 2 is -4, so this is a 0 charge, so we need +4. Here, sulfate is -2, therefore this has to be +2. This is -2, -2 times 4 is -8. This has an overall charge of -2, so we need +6. Okay, so we have to figure out which one is being oxidized and which one is being reduced. Okay, when you go from 0 to +2, that is being oxidized. That means it's losing electrons. Exactly in this case, you go from 0 to +2, so you're losing 2 electrons, so you do -2 electrons. Okay, now here we go from +4, from lead, +4 to +2. What are we doing? We're adding 2 electrons, okay? We're reducing it. So we're reducing by 2 electrons. Now we have to cross multiply. So basically these are even. So the coefficients for both of these are going to be 1. In the case if this would have been a 3, okay, and this would have been a 2, then you would have to multiply 2 times 3 instead of 2 times 1. And this would be the same. It would just be 3 times 2, okay? This would have been a 3. So what happens here is you follow along. So this is a 1 coefficient. You follow along on the bracket, and then you put a 1 there. Follow along on this bracket. You put a 1 here, okay? Same thing with this one. Follow along, you put a 1. Follow along, you put a 1 here. So that's step 1. It's actually faster than this. I'm just trying to explain. Okay, so for step 2, what we're going to do is we're going to, according to this, we're going to check all the elements, and we have to figure out if everything is balanced. So as you notice in the first equation, we're missing a sulfate here, so we got to add it here, sulfate. And then what we're also missing is that there's 2 lead here, 1 and 2. There's 1 here, so we need to add a 2. And since we're adding a 2 there, then we have to add a 2 here, coefficient to the sulfate. Okay, and this is our final, this is our balanced equation for now, for this step. Notice that if you have bromine, the 2, and then a bromine there, and the coefficients that you were needed to, and it turned out that you have to cross multiply by 4, then instead of, you put 4 here, 4, but instead of putting 4 there, you gotta make sure that this is balanced. This has to equal 4, so you're gonna divide that by 2, so that it's balanced. So 2 times 2 is 4, and then it's 4. Okay, so for step 3, now that we have everything there, for step 3, it's really easy. We're gonna balance this using basic conditions, okay? So what we're gonna do is we're gonna add, we're gonna balance the charges, okay, according to step 3. Add either hydronium or hydroxide to balance the charges. Okay, so under basic conditions, we have to balance the charges using hydroxide. So on this side, we have -2 times 2 is -4. So we have a total charge on the left side of -4. So that means we have to balance the other charge, the other part using 4 negative charges. So we're going to do 4 OH negative, okay? Okay, now the last step is add water to balance the hydrogens. We look here, this is the last step. The only thing we need are 4 hydrogens on this side of the equation, okay? So if you look at this, we have 4 hydrogens we added because we added the OH negative, and that means we need to get 4 hydrogens here. What we're going to do is we're going to add 2 waters, because 2 times 2 is 4, so we add 2 waters there, and that's it. That's your balanced reaction. Let's make sure everything is balanced. Okay, number of charges. So we have -2. Okay, I missed one thing right here. I'm gonna fix it. This is supposed to have a 2 in front of it. Okay, a 2 there. Okay, so basically we have -2 times 2 is -4. We have a -4 total charge on the left side. Minus times 4 is -4. So the charges are balanced. Let's look at the oxygens. Okay, so we have 2 times 4 is 8. 8 plus 2 is 10. And 10 plus 2 is 12. Look over here. So we have 2 times 4 is 8. 8 plus 4 is 12. Let's check the hydrogens. 4 hydrogens on the left side. 4 hydrogens on the right side. Therefore, this whole thing is balanced. Now, if we were to do this under acidic conditions, let me write it here. Acidic conditions. It would be the same thing, but instead of doing the hydroxides like I have here in my steps, okay, I'm going to take this out. Okay. So now, let's add hydronium. So we're trying to add this. We're trying to add these, okay? So we're looking for, so we have a -4 charge here. So let's write it down. -4 charge. So we need, and there's no charge here. So we definitely need +4 to make 0. So what I'm going to do is, I'm going to add 4 hydroniums. Hydroniums plus 4 H plus. Okay? So we added that. Now the next thing we have to do is we have to balance, let's make sure the charges are correct. So +1 times 4 is +4, -4 is 0. The charges are balanced. The last step is we need to add water. So let me take this out because I was under the basic conditions. Okay. I just added 4 here. Okay, so we need to balance out the number of hydrogens, okay? We have 4 hydrogens here, 0 over here. Therefore, we need to add 2 waters because 2 times 2 is 4. Okay, now let's make sure we have the correct number of oxygen. So 2 times 1, 2. 2 times 4 is 8. 8 plus 2 is 10. So we need to have 10 here. So 2, okay, 2 plus 8 is 10. So we have the charge is balanced, okay? Then we have the number of hydrogens balanced, and we have the number of oxygens balanced. And that's it.